Okay, we're supposed to start the discussion today. Right. First type of integrating functions, right? Okay. First one, write down people type 1 or method 1. Right? Yeah. Type 1 or method 1, right? Right. Under this type, we're supposed to discuss people integrands of the form this 1 upon quadratic this way ax square plus bx plus c 1 upon quadratic expression, right? Quadratic expression. Denominator we have, right? A denominator we have this quadratic expression 1 upon quadratic expression. This is our integrand now. Okay. Okay. Right. First type is this. Different types of integrating the functions. Only the heading there. The first type is this. Right. So then, when we integrate people this way, if I consider one example like this, 1 upon x squared minus 5x plus 6. This way. This kind of integrands only under this type we discuss people. Right. Now, when we have this way, quadratic function at the denominator, quadratic function at the denominator, right? What we do is this. If this is factorable, if it has factors, then factorize first. Factorize first. Okay. First, our first try is this. This one we have to factorize. Factorize this. Sometimes you can't factorize this. Then complete the square of this. Complete the square. When you complete the square, people, you will get this denominator basically in two forms. Basically in two forms. This may be sometimes a perfect square, this way. Ax plus b perfect square coming. Or else people, this may be coming as a sum of two squares like this. Right? At this way or this way we get after completing the square at the denominator. Okay. Now people, if the denominator comes like this, after completing the square, for example, it is like this, no? Suppose like this, then you can integrate this one, take into the numerator and write in this as x plus 2 to the power minus 2 dx. Then you know how to integrate this. We add 1 to this power and divide by the new power with x coefficient. Okay. If we have this form, right, it is like this, no? X plus 1 squared plus 2 squared. In this kind of denominator, we may get. Then in this case, people, the integral is tan inverse. What is that? 1 upon AC. AC means x coefficient is A, C is this. 1 into 2, tan inverse, this one. X plus 1 upon 3. And if this is factorable, people, then denominator, if it is factorable, we get like this. Suppose this way the two factors we get. Then how to integrate this, people? Then the way of integrating this is we write partial fraction of this. We write partial fraction of this. What are the partial fraction of this, people? Non-repeating linear factors we have at the denominator. So then how do you write the partial fractions? A upon x minus 1 plus b upon x plus 2. This we write the partial fraction. Then after knowing this a and b, suppose we get here 1 and minus 1, for example, then integration of this means really, people, integration of this. Right? So then you know how to integrate this. Denominator containing first degree polynomial. So this is Ln, no? Ln modulus x minus 1. And this one also Ln. So therefore, people, in our first type, the denominator is 1 upon quadratic expression. Basically, the method is this. First, try to factorize the denominator. If it has no factors, people, complete the square. When you complete the square, basically, we may get people either perfect square of this type or sum of two squares. If we get perfect square, bring that to numerator and you can integrate. If it is sum of two squares, people, through tan inverse, you can integrate. Understood, people? That's the method. Right? All right. So then we'll write, people, one example, this type 1, type 1 and type 1. We discuss this type. Write down this way. Put a star mark and then write like this. If the denominator is factorable, then finding factors, write the partial fractions, and integrate. Pardon. If the denominator is not factorable, then complete the square. Of the denominator and integrate. Right now, people. Right. Okay, we'll take some questions and thereby you can very easily understand this. Right. First example we'll take. First example, right? We'll take like x squared minus 3x plus 2 d. Right, people? Yeah. This one is factorable, the denominator. And then first of all, we write factors and then we write partial fractions, right? This way. 1 upon x squared minus 3x plus 2 is equal to 1 upon x minus 2 x minus 1. Now write the partial fraction. This d upon x minus 2 plus d upon x minus 1. Right, how to find a and b, people? First multiply both sides by x minus 2, x minus 1. Then this will be 1. This a should be multiplied by x minus 1. B should be multiplied by x minus 2. Okay. We can write x coefficient, equate here a, here b. Left hand side, no x term, coefficient 0, number 1. Constant terms we can equate a minus a, here minus 2b. Minus a minus 2b is equal to left hand side constant term is 1. Number 2. Adding 1 and 2, people, a minus a you can cancel down. Here minus b is equal to 1. This gives b is minus 1. If b is minus 1, people, a is 1. A is 1. Right. Then we found the partial fractions. Therefore, we can write 1 upon this x squared minus 3x plus 2. We can write substitute for this a is 1, 1 of x minus 2, and b is minus 1, people, no? This b, it is minus 1, minus 1 upon x minus 1. This a we have. Then we need the integration of this one, so therefore we integrate like this. Right? Dx 1 upon x minus 2 dx minus 1 upon x minus 1 dx. This way. Now you know how to integrate this. Right. This is ln modulus x minus 2 divided by x coefficient 1. No? The same thing we get. Minus ln x minus 1. This way, people, difference of two log terms, you know how to write. Difference of two log terms, we can write ln this divided by this. You know that formula under logarithm we learned. And we write a constant, say here k is any constant. K is any constant. This is how we take that answer. So therefore, the first type is that when the denominator contains quadratic expression, we have to first factorize. If the factors are not available, we'll discuss the other questions. Right. Okay, next one, people. Second example, number 2. X squared plus 2x plus 5. Right. Here, people, how to take it. That's no factors. Take the perfect square. We know the steps in complete the square. Their x squared coefficient should be 1. If not, we have to make it as 1. Right. So now here, x squared coefficient is 1. So then we write perfect square within bracket. What do you write? Of this x squared only x. And x coefficient we divide by 2. We get 1. Then this 5. And always we subtract the perfect square of this. 1 square this, 1 more. Then we get like this. Here we get 4. 4 means 2 square. So this is what we get. The integration of this mean, people, This is now equal to this, no? Integration of this. X plus 1 perfect square plus 2 square dx. Right. Can you remember? We discussed, we learned one result this way. 1 upon ax plus b perfect square plus c square integral. What are these people? 1 upon AC. AC means x coefficient into this. 1 upon AC. Tan inverse this divided by this. Ax plus b by c. And now using that you can integrate this. Here A is 1, C is 2. Then 1 upon 2. Tan inverse x plus 1 divided by this 2 is the integral of this function, right? Plus C is any constant. Is any constant. Understood? Okay. Right. We will take the third possibility here. It is this. X squared plus 6x plus 9. Dx. Third one. Then what we do here? Yes, people? Here you can very clearly notice this denominator is a perfect square of x plus 3, no? It is a perfect square of x plus 3. Then you can write this denominator is the perfect square of x plus 3. Then we can write 1 upon x squared plus 6x plus 9 as the perfect square of x plus 3 like this. Therefore, integration of this we can write this way. Now take this to numerator. Now people how to integrate this. Add 1 to this power and divide by the new power. If we have a coefficient for this x, by that coefficient also we have to divide. Okay, then we get x plus 3, adding 1 here, minus 2 plus 1 is minus 1, divided by minus 1, and here x coefficient also 1. So then this is nothing but minus 1 upon x plus 3, right, plus k. K is any constant. K is any constant. Right. Now, under this type people, the question may be coming in a different way. Now, here we considered numerator is 1, denominator is quadratic expression. Right. Some occasions, instead of this 1 at the numerator, there can be first degree polynomial in x, like x plus 1, x plus 2 at the numerator. Or sometimes numerator can be second degree polynomial, x squared plus x minus 1, and third degree polynomial, x cubed term. Right. One question was in 2016 having first degree polynomial at the numerator. So we'll discuss from each kind at least one question. Okay, right. We'll come to the next one. Next example. Right. We'll take this one, people. We'll take x squared minus 6x plus 8, and here x plus 2 dx. X plus 2 dx. Now we have first degree polynomial at the numerator. Earlier we had, people, only one. That means 1 means 0 degree polynomial. 1 means a constant at the numerator. But this time we have first degree polynomial. Okay. Now, people, in this case, this is how we work out this question. You know, when we differentiate this denominator, what is the derivative of this? What is the derivative of this x squared minus 6x plus 8? Differentiate this x squared, 2x. Differentiate this minus 6x minus 6. Differentiate this 8 is a constant, and that constant is alone, therefore derivative is 0. Then this is what we get as a derivative of this denominator. Then, people, this is what we do. First of all, this derivative 2x minus 6 of this denominator, this one, we try to form at the numerator. We form that, okay, at the numerator, like this. Then this is what we have now. X plus 2 divided by x squared minus 6x plus 8. Okay. Now we notice the derivative of this denominator is 2x minus 6. And then first of all, what I do is this. We multiply this x plus 2 both by 2. Then we get 2x plus 4, no? Right. Now, meantime, I divide by 2, like this. Then what happens? When you take 2 out and cancel down with this 2, we get x plus 2. This is coming. Okay. All right. X squared minus 6x plus 8. Okay. Now, up to here, I think you can very clearly understand. I multiplied this numerator by 2, divide by 2. I multiplied this numerator by 2 in order to bring 2x here, because when you differentiate x squared, we get 2x. To bring that 2x only, I multiplied by 2, and meantime I divide by 2. We can't only multiply by 2. Then what happens? Our given integrand will change. So then really we are not working out the question given us, right? Yeah. Now, derivative of this denominator is 2x minus 6, no? But here we have 2x plus 4. Then what I do next is this, people. I write here 2x minus 6, right? But we should have here plus 4. 2x minus 6 I wrote. And then, people, I write here this way. Another, we have to get finally, people, plus 4. Then I write, people, here 10. Divide by this way. Then see here, minus 6 plus 10 is this 4 coming. Then the same thing, so far here we have. Now this one, now we break up into 2. Half we keep like this. We divide this part by this denominator. 2x minus 6 divided by x squared minus 6x plus 8. And 10 divided by this. X squared minus 6x plus 8. This way, we divide or break into 2 parts. So now this one, people, we can write like this. Right. Now what we do is, people, we integrate this one, because we need to integrate this now. We get this way. Now what we do is this. By multiplying this half, we integrate this. By multiplying this half, this, we integrate this. Right. Let's see how to integrate them. Then we get integral of x plus 2 divided by x squared minus 6x plus 8 dx. Right. First, we have to take this 2 inside, but don't cancel down with this 2 and this 6, this 2, right? Because we need this 2x minus 6 there. We write half integration 2x minus 6 divided by x squared minus 6x plus 8 dx. Right. And this half we should multiply this, then this 2 come in here, then that 2 and this 10 we can cancel down, then we get 5. We can take that 5 out. Plus 5 times integral. Now once we cancel down like that, here we have now 1 divided by x squared minus 6x plus equal 8 dx. Okay. Now let's see how to integrate. Now how to integrate. Here, the derivative of this denominator is available at the numerator. People can remember we discussed one method of integrating. Under 7th result we learned. Can remember something like this we learned. Denominator we have a function and its derivative f dash x available as the numerator. In this case, what is the integral? Ln modulus fx. You can remember this. And then people, this theory we can apply. We are here. When you differentiate this x squared minus 6x plus 8, what do you get? 2x minus 6, that is at the numerator. Then what is the integral of this? Ln this denominator. Understood? Ln this denominator. Right. This half Ln modulus x squared minus 6x plus 8 plus 5 times. Right, people. I'm going to take the answer of this as I. This answer I'm going to take as I, and this equation I consider as number 1. Now I am going to evaluate this I separately. Right? I is, people, that 1 upon x squared minus 6x plus 8. Now, people, this one is the previous question. What? Numerator we have 1, denominator quadratic expression. What is the method? If this is factorable, we write factors. And through the factors, if we have factors, we write partial fractions and we integrate. If not, we complete the square and we integrate. After evaluating these people, that answer we put in number 1. Then you can do the rest. No? Right. Come to that now. Right. Now, this one factorable, no? Factorable. Then what are factors here? X minus 2, x minus 4. 1 over x minus 2, x minus 4. When you write partial fractions, a upon x minus 2 plus b upon x minus 4. But people can remember here the shortcut of getting this a and b. Yeah, if you need to find this a, what is the method? Come to its denominator, x minus 2. That denominator we have to equate to 0 and find x value. When we equate x minus 2 to 0, what is x value? X value is 2. Right. Now what we do is this x minus 2 available in the left hand side, close it. Then that 2 substitute for the remaining x's. 2 minus 4, it is minus 2. 1 upon minus 2. Minus half, that is value of a, right? A is minus half. When you find this b, come to its denominator, x minus 4. Equate that x minus 4 to 0. X is 4, right? The same x minus 4 available in the left hand side, close it. For the rest x's, put x equals 4. 4 minus 2. It's 2. 1 upon 2. It's half. B is half. B is half. Right. Now we know both A and B. Now write the partial fraction. Okay. And we get 1 over x minus 2, 6 minus 4. We can write people. A is minus half. B is plus half. Right. Then minus half I write like this. Minus 1 upon 2. I substitute for this A. Then I can write it as 1 upon x minus 2. B is half. Therefore, half times 1 upon x minus 4. This way we have. Now this means really people, this no, then we can integrate that. This means really x squared minus 6x plus 8. Now we integrate this. Then this one we integrate minus half 1 upon x minus 2 dx plus half 1 upon x minus 4 dx, right? Now what is the answer here, people? Minus half. This is L in mod x minus 2 plus half L in mod x minus 4. People, this answer only we assumed as I. That same thing only here we have. Therefore, for this one I can put the notation I like this. Now, how to write this? You can take this half out. Then L in mod x minus 4 here we have, and minus L in mod x minus 2. Then how to write this one, people? You can write that one as this way. Half L in this divided by this. Right. Now this I we have. Now in number one, this place of I, we substitute that answer. We substitute that answer. Right. Now you can write now by 1. You can take this answer. Now by number 1. Right. People, for the place of this I, we have to substitute this answer. Yeah, then we write it like this. Right now, right now, therefore, now by number 1, substitute for the place of this I, that answer. What is that? Half. Half means 5 by 2. 5 by 2. L in mod x minus 4 divided by x minus 2. Right. Plus people k. What is k? K is a constant. K is a constant. That is how we take this answer. Right, people, there is another method of getting the same answer. There's another method of getting the same answer. What is that? People, this denominator is factorable. Then directly write in here factors, we write people partial fractions. Okay. That is possible. That's our second method. But people, if the denominator is not factorable, this method you can't apply. That occasion, people, the method so far we used in taking this answer should be used. Understood? But anyway, people will take the same answer by directly writing partial fractions because this denominator is this time factorable. If this is not factorable, people, this partial fraction method to get the answer of this kind of question you can't use. You have to use the process so far in getting this answer we used. Understood? Okay, now people, right. Then we come to the second method. We come to the second method. Second method. Right. Second method, people. 6 plus 2 divided by x squared minus 6x plus 8, no? X plus 2 here, what do you get? What are the factors? X minus 2, x minus 4. This. Then you know how to try the partial fraction for this. Denominator containing non-repeating linear factors. Non-repeating linear factors. Then you know how to try the partial fraction. Understood? Right? Okay, we'll come to that, people. X plus 2 divided by x minus 2, x minus 4. In this one you can write as a divided by x minus 2, b divided by x minus 4. Right, find this AB values. What is the value of A? Yeah, come to denominator, equal is 0, x is 2, close that here, put 2 here, 2 plus 2 is 4 here, 2 minus 4 is minus 2, 4 divided by minus 2, it's minus 2. Find V. Come to denominator, equate this to 0, x equals 4, right? X equals 4, close that x minus 4 here, put that 4 here, 4 plus 2 is 6, 4 minus 2 is 2, 6 divided by 2 is 3. Right? Now we can write. This means this. Therefore, plus 2 divided by x squared minus 6 plus 8. A is minus 2. B is 3. This way. Now integrate this side and the right hand side. They are take this 2 and this 3 out. Then you can integrate each. The both answers being same people even though they appear in two different ways. Right? Right, take this answer. X plus 2 divided by x squared plus 6 plus 8 dx. Take this minus 2 out. 1 upon x minus 2 dx plus 3 1 upon x minus 4 dx. Right. So now here minus 2. What is the integral of this ln mod x minus 2 plus 3 times ln mod x minus 4. Right. Plus people k. K is any constant. K is any constant. That's how we take this answer. Right. The next question is x plus 1 divided by x squared plus 2x plus 5 dx. Right. In this case, people, this denominator is not factorable. Not factorable. Right. Asking both answers different. No, no. Though you see that answers are different, people, when you differentiate again the right hand side, the left hand side answer coming. Understood? Not different. Okay. Right. Now, this is not factorable. Then people, the second method here we use, you can't use. Then the first method definitely you have to use. The what method? First, form at the numerator the derivative of the denominator. Okay. Like that. Try to get this answer, people. Right? I'll give 2 minutes. Now, since this denominator we can't factorize, the second method in the earlier question, here you can't use. Remember that. Right. Then, first of all, this is what I do. I'm going to write that x plus 1 divided by x squared plus 2x plus 5. Then, the derivative of this denominator, 2x, people, plus 2, no? 2x plus 2. Then it's very easy in this case. What? I could have changed this one to another value, but I'll take that in the way this way, right? I multiply this by 2. 2x plus 2. Meantime, I divide by 2. Then we get this. Right? Then you can very clearly understand 2x plus 2 is the derivative of this denominator that is available at the numerator. Therefore, no more works available in it. Right? Directly you can take the answer now. Right? So then this one, we can write the integration like this way. Okay. Then derivative of this denominator available at the numerator. So therefore, this answer going to be what? Half ln modulus the denominator is the answer. Plus c. C is any constant. Right? Now see, when the question is like this, integration x plus 3 divided by x squared plus 2x plus 5. I take this as the next question. If we have something like this, how take? Yeah. We have to come to this way. X plus 3 divided by x squared plus 2x plus 5. Yeah. At first, people, we form at the numerator the derivative. When you differentiate this denominator, what do you get? That we have to have at the numerator. Right? With that intention, what I do is this. This x and this 3 both we multiply by 2. Then we get 2x plus 6. Since we have multiplied this numerator by 2, we have divided that meantime by 2. This way. Okay. Now the left hand side, same thing available here. But the derivative is 2x plus 2. We have 2x plus 6. Then the 6 we write 2 plus 4. Right. Put the bracket here. Half 2x plus 2 plus 4 divided by this whole thing. This way. Now this thing we break up, this divided by this and this divided by this. That way now you can write it. When we get here, people, x plus 3 upon x squared plus 2x plus 5, right? Half times we divide this by this. 2x plus 2 divided by x squared plus 2x plus 5. And this 4 and this half we have multiply now, people. See what do you get? Half into 4. Once I take this 4 before, here we have now 1. 1 upon x squared plus 2x plus 5. This way. Right. Now you can cancel down this and this by 2. Now we can integrate x plus 3 upon x squared plus 2x plus 5 dx, half integral of this, right, plus 2 times integral of this. Dx. Up to you, I think you can very easily understand. And people, what are the answer of this? This derivative of the denominator available at the numerator. Then L in denominator is the answer. Half L in denominator. X squared plus 2x plus 5. And plus 2 times, I am going to take this as I. And take this as equation number 1. Okay. Left hand side, we have this. Now this I, this no, that one I am going to integrate separately. Therefore, I is 1 upon x squared plus 2x plus 5 dx. Now this one, people, the very first method, no, type 1 question now. What we do? If factorable, we don't know factors, no, we don't have factors of this. Then what we do? We complete the square, right? We complete the square of this. What do you get? We have to put perfect squared. In bracket, what do you write? X we write plus divide x coefficient by 2, we get 1. Then this 5. And we have subtract always perfect squared of this. 1 squared is 1. No? This way we have dx. Right. Now we get what, people? I is equal to six plus 1 perfect squared plus 5 minus 1 is 4. No, 4 means 2 squared. This is now, people, what? Tan inverse, no? Right? 1 upon this 2 into x coefficient 1. Tan inverse this divided by 2. X plus 1 divided by 2. Now this answer we have to put where? In number 1. Now by 1. We get, people, the answer like this. Integration of x plus 3 divided by x squared plus 2x plus 5 dx equals half L in modulus x squared plus 2x plus 5 plus 2 times I. When you bring this 2 here, we get 2i. No? 2i is tan inverse x plus 1 by 2. Plus C is any constant. is any constant. Okay, this is how we take that answer. Right. Okay, now will come another one question, people, like this. Suppose we have a question like this: x squared plus 1 divided by x squared minus 2x plus 10. This we have. Now the numerator, people, second degree polynomial we have, right? The very first question we had the numerator constant, 0 degree polynomial. That question we did. Secondly, we increased the degree of the numerator by 1. Then we consider two questions, numerator having first degree polynomial. Now numerator having, people, second degree polynomial. Now again this denominator we have second degree quadratic function, and also here that denominator second degree function not factorable. If it is factorable, then definitely, people, through partial fraction we can take the answer. If it is not factorable, people, we have to go for the method earlier we did. Now what we do, people? Now what we do? We have to take this answer. Right. First, write down the next question as this. Yeah, in this case, people, remember the way of getting this kind of, for a question this kind, the way of getting the answer is this. Right. Very carefully listen to me, people. First, we write the denominator on the right hand side, denominator like this. Now we write the same denominator at the numerator, x squared minus 2x plus 10. People, but what should we have at the numerator? X squared plus 1. In addition to this x squared plus 1, what are the terms here we have, people? Minus 2x plus 10 we have. There should not be those terms. Finally, the numerator should be only x squared plus 1. Then this is what I do. I subtract 9 from this 10. 9. And I add 2x. Then simplify the numerator. What do you get? X squared minus 2x and this plus 2x will cancel off. 10 minus 9 is 1. This is coming. Then what do we have? X squared plus 1. This numerator is now equal to this, and the left hand side and the right hand side being equal. I think you can very clearly understand up to there. Understood, people? Right. Now what we do is this. Taking this together and these two terms separately together, we divide this by this and this by this. Then what do you get? This divided by this means 1. Minus 9 plus 2x, people, we write as 2x minus 9 divided by this. This way we write. Up to I think you can very clearly understand. Now, numerator we have first degree function. You know, in the previous case, we did that kind of question. Now, that method we can apply after this. Understood? Yeah. Then how to write that? 1 plus, we have to write the derivative 2x minus 2, no? Then we can write 2x minus 2, this 9 we write minus 7 minus 2, correct, no? This 2x minus 9 we write 2x minus 2 minus 7. Minus 2 minus 7 is minus 9. This is coming. Divided by this. X squared minus 2x plus 10. Then this term we consider alone. And we divide that by this and this by this. 1 plus 2x minus 2 divided by x squared minus 2x plus 10. And minus 7 divided by x squared minus 2x plus 10. Now see how to take the answer. The left hand side, this one, x squared plus 1 divided by x squared minus 2x plus 10. This function we can write this way. So now once you integrate this left hand side and right hand side, you know how to integrate this. When you integrate 1, what is the answer? X. How to integrate this? Derivative of this denominator available at the numerator. Then ln denominator. People, here when you take the 7 out, you know constant divided by quadratic function. You know how to integrate. This is not factorable. Then complete the square. Then through tan inverse, you get the answer for this. This is ln. This is x. Then we get the answer of this. See here the way of converting that to possible way of integrating, right, people? Right. Then start that. Hurry up. Start that. Hurry up and take the answer. Right? Yeah. This is x. ln modulus x squared minus 2x plus 10 minus 7 integration. Complete the square of this. X minus 1 perfect squared plus 9 coming, 9 is 3 squared. After completing the square, that is what we get. Then we get here plus ln this is people 1 upon 3 tan inverse x minus 1 divided by 3 plus c. C is any constant. C is any constant. For this kind of question, people, since the denominator is not factorable, you can't use the partial fraction method. You can't use the partial fraction method. Understood? Right? Okay, now people, and we'll take another one more from this kind and go to the second type. At what time you will finish the class? We finish the class by 2 o'clock. Right? We stop class by 2. 2 p.m. Right, people, next one. We'll take another one more. When there is a third degree function at the numerator, like this, x cube plus 1 divided by, I'll take the same denominator here, x squared minus 2x plus 10 dx. Right. Come to this, people. Try to get this answer. Just try. Right. Now, people, I take this x cube plus 1 divided by x squared minus 2x plus 10. Right. Now, I write it like this. I write the denominator x squared minus 2x plus 10. Right. Now, I'm going to write this numerator x cube plus 1 in terms of this denominator, right? So then I am going to write first this denominator where at the numerator like this. Okay, I put a bracket. Since we need x cube here, I write x cube, x here. Then what do you get, people? X and x squared, x cube coming. That's fine. X and minus 2x. What do you get? Minus 2x squared. Minus 2x squared come into this numerator. But here we don't have minus 2x squared. Then the minus 2x squared come in here. We have to eliminate from the numerator. To eliminate that, the best way is, people, add 2x squared. Then what happens here? Minus 2x squared and plus 2x squared will cancel out. What do you get next one? 10x come in. But here we don't have x 10. Subtract that 10x also. But here we have 1, people. Now this numerator lacking 1, then put 1. Understood? Okay, no? Now what we do is this. We divide this by this and this whole thing we divide by this. Understood? Right. Then we get what? When we divide this by this, we get x only. Plus x squared minus 2x plus 10. This one should be here. 2x squared minus 10x plus 1. Understood? Right. Now what we do is this. We keep this x here. X squared minus 2x plus 10. Right. Now, people, I write again this x squared minus 2x plus 10. Right. To get this, I write 2 here. Then see what you get there? 2x squared coming. That's fine, good. Right. Here this and this minus 4x, but here we have minus 10x. This numerator to be minus 10x, here 2 and this 2 make 4. Minus 4x come in, but we have here minus 10x. Another minus 6x we need. Two and this 10, 20. But we should have only 1. Subtract 19. Right. Now we divide this by this and this whole thing by this. Right. That's our next step, right? X. Then divide this by this, we get plus 2. Take, people, this minus sign out. Then we get 6x plus 19 divided by x squared minus 2x plus 10. All right. Now, people, what is this? Numerator first degree polynomial, denominator quadratic function. Then you know how to do this now. How to do this now, people? We first write the derivative of this denominator at the numerator and keep doing this. Understand? Right? Yeah. Now we can write equals x plus 2, right, minus. People, I take 2 out. Here we should have 2x, no, I take 3 out. I take 3 out from this. Take 3 out. Also take 3 out. This will be 2x. This one should be divided by 3, no, people? When you take 3 out, all right. 3 times. Now 2x, 19 by 3. X squared minus 2x plus 10. Right. X plus 2 minus 3 times. People, what is the derivative of this denominator? 2x minus 2, no? 2x is there. We'll keep 2x. Now the minus 2 we need. I write minus 2. This written extra minus 2 to cancel down. I write another plus 2 and then I write this 19 by 3. You see, I write it. Okay. Now correct now, people, here. Minus 2 plus 2 we can cancel down. 2x plus 19 by 3. This is coming. Now what I do is this next. This portion we divide by this. This portion we divide by this. Then what do you get? X plus 2 minus 3 times 2x minus 2 divided by x squared minus 2x plus 10. Right? And now, people, this 2 plus 19 by 3, we have simplified. 2 plus 19 by 3. When you simplify, what do you get? Take common denominator here 3. 3 into this 2 is 6. 6 plus 19 means 25 by 3. We get 25 by 3. And that 25 by 3, people should be multiplied with this 3, no? Then here we get the simplification of this 25 by 3. That 3 and this 3 we can cancel down. Then we have here 25. When you multiply by this minus sign, minus 25 divided by this, we get minus 25 divided by this. X squared minus 2x plus 10. Right. Now the function we can, people, integrate. The left hand side, what we have is this, no? This one. Then I can write this, right? X plus 2, integral of x plus 2, right? We can integrate one by one, no, people? Integral of x dx plus integral of 2, integrated this and this one next. Take this minus 3 out. Minus 3 times 2x minus 2 x squared minus 2x plus 10 dx. Right, people? And this one I'm going to write. Take minus 25 out because it's a constant, no? Integration. Now we have 1 over, because we'll straight away come to the square and write that. What is that? X minus 1 squared plus 3 squared dx coming. Now you can very easily integrate this all terms. Here x squared by 2, this is 2x, minus 3 L in denominator, minus 25 tan inverse x minus 1 divided by 3 plus c is the final answer. Is the final answer. Okay, people, right? Understood that? Right. Now, shall I erase this one? Right. This how people take that answer. Right now, and that is the end of the first type. Now we'll move to second type, people. So now in this integration hall lesson, people, I'm going to discuss this way 15 types. Then the basic types of integrating functions we can discuss. Okay, 15 types. Right. Now second type, we come to second type. We come to the second type. Write the answer. Type 2. And under this type 2, people, we're supposed to discuss the integrands of the type this. The denominator, we have a function in x. The numerator, we have exactly derivative of this f dash x. Right? This is how the integrand people form. So therefore, this is integration dx. Understand? On this type. Right. Shall I erase this now, people? Right. Right. First example we take. Integration 1 upon x times L in x dx. 1 upon x times L in x dx. Try to get these, people. I'll take this. This one, we can write, people. This 1 upon x, I can write like this, no? 1 upon x L in x dx. The same thing I can write like this. Correct, no? This means really this. Now you know L in x. Derivative of L in x is what, people? Derivative of log x. 1 upon x, no? Derivative of this denominator, now we have at the numerator. Then what's the answer? L in denominator. So therefore, this is L in denominator. L in x plus c. C is any constant. C is any constant. Right? C is any constant. Next one, people. One upon square root of 1 minus x squared sine inverse x dx. Well, you know, when we differentiate sine inverse x, what's the derivative? 1 upon square root of 1 minus x squared. So you can write this one. How? 1 upon this, we can write this way. Divided by sine inverse x. The reason is, people, when you write like this, right, it is really here. Look at this. Divided by this, no? This one you can write this divided by this, no? 1 upon square root of 1 minus x squared divided by sine inverse x. This division sign we can write as multiplication and take the reciprocal of this. Then when you multiply this way, people, really we get this, no? Then conversely, this thing we can write like this. Then derivative of this denominator available at the numerator. So therefore, what is the answer? Ln denominator is the answer. Ln denominator is the answer. Take answer Ln denominator. Therefore, here it is Ln modulus sine inverse x plus c. C is any constant. C is any constant. Right. Okay. Type 3, next one. Type 3. Under this type 3, people, we are supposed to discuss this kind of integrands. We have a function fx with x power n. It is multiplied by the derivative of this fx. Derivative of fx we write usually f dash x. Then if we have this kind of integrand, fx to the power n, and this derivative of this fx available before as a product, then this kind of integrand, if we have, the integral going to be, people, adding 1 to this power fx to the power n plus 1 divided by new power n plus 1, n is not equal to minus 1. This is how we take the answer. Right, people? See the property of this integrand. It contains a function to the power n. And this whole thing is multiplied, people, by the derivative of the function within bracket. If we have this kind of integrand, its integral is, people, adding 1 to this power dividing by the new power. Okay, all right. Now, for example, Right, first write down type 3. Write down type 3. People will write one example like this. Sine to the power 3x here cos 6 dx. Cos 6 into sine to the power 3x dx. Right? Right. How to take this answer, people? This sine to the power 3x I can write like this. Sine x to the power 3. And here cos 6. Now your fx function is sine x. It's third power. And of this sine x, what is the derivative of sine x? Cos x here. Right. Now exactly this one is in accordance with this. Fx is the sine x. Of the sine x derivative here, fx derivative here. Then what is the answer? Adding 1 to this power and divided by new power. Then sine x to the power 3 plus 1 divided by 3 plus 1 is the answer. Sine x to the power 3 plus 1 divided by 3 plus 1. This is 4. Sine x to the power 4 mean, people, it is sine to the power 4 x divided by 4 plus c. C is any constant. C is any constant, right? Here's how we take that answer. Next one. Integration 1 upon x times square root of 1 plus ln x dx. Take this answer. You can write this way, people. This x is 1 upon x, no? This 1 plus ln x root means power half, no? Take to numerator. Here, positive half power, once we take that to numerator, minus half. This is. You can see here, this is your function fx. Its power is minus half. Even when you differentiate this function within bracket, 1 is a constant alone 0. When you differentiate ln x, it is 1 upon x. By that 1 upon x, this whole thing is multiplied. So therefore, this is the fx, f dash x. This is your fx. N power is minus half this. So what is the answer? Adding 1 to this power and dividing by the new power. Understood? Right? So then we get 1 plus ln x minus half plus 1 is plus half divided by half. This goes to numerator this way 2 times 1 plus ln x plus half means people square root plus c. C is any constant. C is any constant. That is people way of getting that answer. Right. Next one. Type 4. Right on type 4. Integration by parts. Integration by parts. This is another very important one, people. In the past paper question, this part every year available integration by part. Integration by part. Okay, right. Right now, suppose people we have u and v function as a product to differentiate. You know how differentiate this a product? First function u we keep as same multiplied by the derivative of the second function v, and second function we keep as same and multiply that the derivative of u this way. Right? Now we integrate. Integrating both sides with respect to x. How to write the integration notation? Integration dx. What this part? d upon dx uv equals integration with respect to x, this part, u times dv by dx, right? Plus integration v times du by dx. Okay, right. Now we will think like this. Here we have uv product. First we differentiate that and we get derivative now. That means here uv function by this, what do you get? uv function has been differentiated. That means this answer is here now. That one, this whole thing now integrated with respect to x. This one now integrated. Then we must get this initial function uv, no? This is differentiated. The answer is here. This is integrated. That should come to the initial function. So therefore, people, this one is nothing but uv. Okay, equals u times dv by dx into dx plus v times du by dx into dx. Right? Now we take this one to this side, left hand side, and then we subject this. Okay, once you subject that, this is what we get. uv minus v times du by dx, right? We take this to this side and we subject this, equals integration u times dv by dx. So therefore, we can write in this in the left hand side, it is equal to this. This implies what, people? Integration u times dv by dx is equal to uv minus integral v du by dx. This is called as, people, the by-parts formula. By-parts formula. This is called as the by-parts formula. Okay, right. You have to remember this formula. Always when we need to integrate by parts, this formula you have to use. Okay, right. So then we'll write first like this. Write down, consider two functions in x, TWO2 functions in x simple u and simple v. simple u and simple v. Okay. Now people take this up to here. Take this up to here. Right, people? Okay, no? Right. Now, this integration by parts we use when we have a function to integrate. The function is as a product. Function is as a product. Now, for example, suppose this way, we have to integrate x into Vx. With respect to x, we have to integrate. See here, x Ex, that function x Ex, it's a product. X and Ex multiplied. Now, in this case, people, when we integrate x Ex, we use this integration by parts. Integration by parts. Right? So, this is how we integrate it. Right. Now, this one we compare with the left hand side of this by parts formula. Then it is u into dv by dx. No? Right. Now I am writing the by parts formula again. This is equal to uv minus v du by dx. No? This is by part formula. Then in the place of u here we have x. Then we select u as x. dv by dx is people Ex. That way, by comparing the left hand side of the by parts formula, we determine the u function and dv by dx function. That's what we do first. Okay. Now, people, what we do is this. In the by parts formula right hand side, we have u into v at first. And secondly, we have v times du by dx. V times du by dx. Therefore, what we do is, in order to find this v function, right? You can see people here in the by parts formula. Here we have v function and here we have v function. That means v function we have to find. Now, when v function is differentiated, the derivative only we have, but we need this function. When this v function is differentiated with respect to x, that derivative only we have. Then how to find this v? People, by using the derivative, finding the original function means that derivative we have to integrate to find the original function, no? Function, differentiate, derivative come in. Once we integrate this derivative only, we get the initial function. So therefore, of the function v, derivative available here. This is the derivative of the function v. If we need to find this function v, what we have to do is, people, this right hand side of dv by dx, we have to integrate. So therefore, people, always remember, to find v, the dv by dx function has a right hand side, no? That right hand side of dv by dx, you have to integrate, then you get v. So therefore, the right hand side of dv by dx, you have to integrate to find what this v, because that v we need for right hand side here and here. Right? Therefore, v is equal to integral of ex with respect to x. And on the right hand side, we have du by dx. That means, people, this u function we have to differentiate. So therefore, du by dx is equal to derivative of x with respect to x is, people, 1. So therefore, remember, after deciding your u function and dv by dx function, u function you have to differentiate. The dv by dx function right hand side you have to integrate to find v. Understood? Right. Now, very easy. these things. All right, first determine what is the integral of Ex. When you integrate Ex, what is the answer, people? Ex integral is Ex, right? So therefore, V is Ex integral is Ex. We know this. Now what we do is, people, we substitute the things on the right hand side, right? Therefore, we can write this one, integral of x into Ex with respect to x is equal to uv. What is u? X. What is v? Ex. X into Ex minus v is Ex. Here, du by dx, it is 1 dx. Ex into 1 is, people, Ex. Then here we have x Ex minus Ex integral is Ex. When we integrate Ex, people, we get Ex. Then we have finished the integration. Then put the c. C is any constant. C is any constant. This is how we use, people, this integration by parts, right? Take the answer. Integration by parts, we do like this. Right, people? Right. You have to always remember this by parts formula, people, right? Okay. We'll take a second example. Integral of x sin x dx. X sin x. Take this as the next one. X sin x. X sin x. Then this this x function we select as u, sin x function we select as our dv by dx. Okay. We said always this u function we have to differentiate. Du by dx is 1. And the right hand side of this dv by dx function we have to integrate to find what this v. V is integral of sin x. What is the integral of sin x? Minus cos x. Minus cos x. Right. Now we can write integral of x sin x uv x into this cos x minus v minus cos x du by dx is 1. minus x cos 6. Take this minus sign out plus integral of cos 6 dx. Integral of cos 6 people sin x, no? Minus x cos 6 plus this is sin x plus k. K is any constant. K is any constant. This is how people we take that answer. So I take next question as this integral of tan inverse x. Integral of tan inverse x. Tan inverse x derivative. Integration. Take this one by using by parts. Right, people? Let's see how to take this. Integral of tan inverse x. Right? This tan inverse x into 1 I can consider like that. Right? So then this function you can take as u function. And this 1 we can consider as our dv by dx function. U function we differentiate. Then du by dx come in. What is the root of tan inverse x, people? 1 upon 1 plus x squared. When we integrate this 1, we get v. What is the integral of 1? It's x. Then we can apply the by parts formula to get this integral of tan inverse x. Integral of tan inverse x with respect to x. Right answer uv. Tan inverse x, v is x. X into tan inverse x. Minus v, it is x. Du by dx, 1 upon x squared. This x we can write it. We are here. This way. Now, x into tan inverse x. How to integrate this? When you differentiate this denominator, the root of this 1 is 0. The root of this x squared is 2x. To get that 2x at the numerator, what I do is, people, I multiply this by 2 and divide by mean time by 2 like this. Now you can very clearly see here, when we need to integrate this one, you can apply here derivative of this denominator available at the numerator. So therefore, in this case, the integral going to be L in denominator. When the derivative of the denominator available at the numerator, that occasion the integral is L in denominator. So therefore, we get the answer x tan inverse x minus half L in 1 plus x squared plus c. C is any constant. This is how we take that answer. And we work. As the next question, we'll take integration of x tan inverse x dx. X tan inverse x dx. Take the next one as this x tan inverse x dx. X tan inverse x dx. Right now? Yes. Right, people? Now in this case, if we take this tan inverse x as your dv by dx, to find this v, since we need to integrate tan inverse x, right? We have a long expression for tan inverse x. This time here we obtain. Then to bypass this inconvenience of substituting that long expression for tan inverse x integral just now we obtained to find the v function, right, people? We follow it like this. We take, people, this x tan inverse x, we can write this way also, no? Tan inverse x into x, the same thing, no? Then this tan inverse x function we take as u, and this x function x we take as our dv by dx. Okay, then what is du by dx? 1 over 1 plus x squared. The derivative of tan inverse x is this. Integral of this x, then we get v. Integral of x is x squared by 2. Now substitute in by parts formula. Integral of x times tan inverse x dx is equal to uv. U is tan inverse x, v is x squared by 2. Then we get what? X squared by 2 into tan inverse x minus v, x squared by 2 du by dx, 1 over 1 plus x squared dx. Take this 2 out, people. Right? Also take this 2 out, we get half x squared divided by 1 plus x squared dx. We get this. Now how to integrate this? Yeah, that can be integrated, people. X squared tan inverse x divided by 2 minus half. Here we add 1 and we subtract 1. It won't change now, people. 1 and minus 1 we can cancel down. X squared divided by this is 1. Now x squared times tan inverse x by 2. People, now we divide this by this. This by this we get 1 minus this by this. This way. Now we integrate this separately and this separately. Then what do you get? X squared tan inverse x by 2 minus half, open the bracket. Integral of 1 is, people, x minus integral of 1 upon 1 plus x squared is what, people? Tan inverse x. Plus c is any constant. This is how, people, we take that answer. Okay, no? Right. So then next day we continue the lesson from here. Any question here?